Hello, my name is Adhityo.
Hello, I am Bagas.
Hello, I am Dimas. Hello, I am Hendri.
Hi, I'm Nita.
Hello, I am Mutia.
In theoretical computer science and mathematics, the theory of computation is the branch that deals with how efficiently problems can be solved and model of computation. Using an algorithm, purpose of the theory of computation is develop formal mathematical models of computation that reflect real-world computers. The theory of computation can be divided into the following three areas. They are complexity theory, computability theory, and automata theory. The first one is complexity theory. Complexity theory considers not only whether a problem can be solved at all on a computer, but also how efficiently the problem can be solved. Two major aspects are considered: time complexity and space complexity, which are respectively how many steps does it take to perform a computation and how much memory is required to perform that computation. In complexity theory, we will find with big O notation to solve the problem. And the second one is computability theory. It's closely related to the branch of mathematical logic called recursion theory, which removes the restriction of studying only models of computation which are reducible to the Turing model. Many mathematicians and computational theorists who study recursion theory will refer to it as computability theory. And number three is automata theory. Automata theory is the study of abstract machines, or more appropriately abstract mathematical machines or systems, and the computational problems that can be solved using these machines. Automata are used as theoretical models for computing machines and are used for proofs about computability.
There are several models of computation. There are finite state automata, push-down automata, Turing machine, lambda calculus, combinatorial logic, Markov algorithm, register machine, and mu recursive functions. Some pioneers of the theory of computation were Alonzo Krauss, Kurt Gödel, Alan Turing, Stephen Klein, Rosa Peter, John von Neumann, and Claude Shannon. Modern computation. Modern computing can be called a system concept that accepts instructions and stores them in a memory. At this time, we do computing with computer, and we can call computer is a modern computing. That concept was conceived by John von Neumann. Modern computing can be divided into three cases. There are mobile computing, web computing, and cloud computing.
Implementation of modern computation in physics. The understanding of the system theory, experimentation, and computation must be comparable. In order to introduce the appropriate numerical and visualization or modeling solution to understand the physics. To perform work such as integral evaluation, solving differential equation, solving simultaneous equation, plotting a function or data, making the development of a series of functions, finding the root of the equation, and working with complex number of for which computational physics is applied. Many of the software or languages used, either MATLAB, Visual Basic, Fortran, open source basic or RSP, LabVIEW, Mathematica, etc. are used for understanding and finding numerical solutions of problems in computational physics.
Implementation of modern computational in chemistry. Implementations of modern computation in the field of chemistry is computational chemistry is the use of computer science to help solve chemical problems. For example, the use of supercomputers to calculate the structure and molecular properties. The term chemical theory can be defined as a mathematical description for chemistry, whereas computational chemistry is typically used when mathematical methods are developed well enough to be used in computer programs.
Implementation of modern computation in mathematics, resolving a problem relating to mathematical calculation, but in the sense that will be discussed in the discussion of modern computing is a system that will solve mathematical problem using a computer, but preparing algorithms that can be understood by computer that are useful for solving human problems.
Implementation of modern computing in economics. Programming specially designed for economic computing and development of it in computing economic education, because the economic field must have problems that must be solved by the algorithm. For example, he solved the theory of statistics to solve financial problems. One example of computing in economics is statistical computing. Statistical computing is the department that studies the techniques of data processing, program making, and data analysis. And statistical information system preparation techniques such as database compilation, data communication, network system, and statistical data dissemination.
Implementation of computing in geology and geography. Geology and geography in this field can be used such as modeling the axis of the geographic state of a monitored surface area in the event of movement or vibration. In addition, information on weather forecast is very useful for everything, especially air and sea transportation. I will explain the first part about the introduction of cloud computing. What is cloud computing? Cloud computing consists of two words, cloud and computing. Cloud is another equation of the internet, which is often depicted in computer network diagrams. And computing is the process of computing. Computing comes from the words computation, which means calculation. According to IEEE Internet Computing, cloud computing is a paradigm in which information is stored permanently on an internet server and stored temporarily on a user computer. The criteria for cloud computing. There are 5 criteria of cloud computing, namely 1. Data source pooling. Service provider collect computing resources to meet the demand need of the computer. 2. Broadband network access. The cloud provider has the availability of service available through the network and can be accessed on device such as smartphone, laptop, and others. 3. Measure service. Services are available to optimize and monitor service that is used automatically. By using the system, we can see how resource computing that has been used. 4. Rapid elasticity. The capabilities of the cloud service provider can be used by the cloud consumer for needs. 5. Self-service. The cloud consumer can configure independently of the service that you want to use through a system without the need for interaction from the cloud provider in advance. Cloud computing service. Next will be discussed of the type of service of cloud computing. NEST divides the types of cloud service into 3. 1. Software as a service. Software service where customer can use the software that has been prepared by the cloud provider. Example of cloud provider of SaaS which have been trusted by customer including Gmail, Yahoo Mail, Facebook, Office 365, Skype, and the other. 2. Platform as a service. Platform as a service is a service that provides computing platform typically including operating system, database, web server, and application framework that can run applications that have been made. Example of PaaS service are Amazon, Google App Engine. 3. Infrastructure as a service. Infrastructure as a service is cloud computing service which provide IT infrastructure in the form of CPU, RAM, storage, bandwidth, and other configuration. Example of service provider IaaS, Amazon, AC2, Rackspace Cloud, and Windows Azure.
Now I want to explain about grid computing. Grid computing is the collection of computer resources from multiple locations to reach a common goal. IBM defines that grid computing as the ability using a set of open standards and protocols to gain access to applications and data, processing power, storage capacity, and a vast array of other computing resources over the internet. A grid is a type of parallel and distributed system that enables the sharing, selections, and aggregations of resources distributed across multiple administrative domains based on their resource availability, capacity, performance, cost, and user quality of service requirements. With computing, like we own a supercomputer. Computing concept differs from parallel computing in supercomputers. Supercomputers run highly connected applications rather than independently functional nodes. They operate over high-speed networks and are typically hosted in one specialized data center. Grid computers, on the other hand, exchange little or no data and feed the project over internet connections from geographically dispersed locations. The grid computing architecture can bring massive processing power to bear on a problem. Grid focused on integrating existing resources with their hardware in order to support the creation of the so-called virtual organizations, a logical entity with which distributed resources can be discovered and shared as if they were from the same organizations. Grids provide protocols and services at 5 different layers as identified in the grid protocol architecture. There are 5 layers in grid computing architecture: fabric, connectivity, resource, collective, and applications. First, fabric layers. Fabric layers grids provide access to different resources types such as compute, storage, and network resource, code repository, etc. Second is connectivity layers, defines core communications and authentications protocols for easy and secure network transactions. 3. Resource layer, defines protocols for the publications, discovery, negotiations, monitoring, accounting, and payment of sharing operations on individual resources. 4. Collective layer, captures interactions across collections of resources, directory service such as MDS for monitoring and discovery service, allows for the monitoring and discovery of VO resources. Conderg and Nimrod-G are examples of allocating, scheduling, and brokering service, and MPICH of grid-enabled programming system, and CAS or Community Authorization Service for Global Resources Policies. 5. Application layer comprises whatever user applications built on top of the above protocols and APIs and operate in VO environments.
What is virtualization? Virtualization is the creation of virtual servers, infrastructure, device, and computing resources. A good example of how it works in your daily life is the separation of your hard drive into different parts. While you might have only one hard drive, your system sees it as 2, 3, or more different and spared segments. Similarly, This technology has been used for a long time. It starts as the ability to run multiple operating systems on one hardware set, and now it's a vital part of testing and code-based computing. The basics of virtualization. A technology called the virtual machine monitor, also called virtual manager, encapsulates the very basics of virtualization in cloud computing. It is used to spare the physical hardware from its emulated parts. This often includes the CPU memory, I/O, and network traffic. A secondary operating system that is usually interacting with the hardware is now a software emulation of the hardware. And often the guest operating system has no idea it's on the virtualization hardware, despite the fact that performance of the virtual system is not equal to the functioning of the true hardware operating system. The technology still works because most secondary OS and applications don't need the full use of the underlying hardware. This sort of creating flexibility, control, and isolation by removing the dependency of a given hardware platform. The layer of software that enables this abstraction is called hypervision. A study in the International Journal of Scientific and Technology Research defined it as a software layer that can monitor and virtualize the results of a host machine conform to the user requirement. The most common hypervision is referred to as step 1. By talking to the hardware directly, it virtualizes the hardware platform that makes it able to be used by virtual machines. There's also a type 2 hypervision, which requires an operating system. Most often, you can find it being used in software testing and laboratory research. Types of virtualization in cloud computing. Here are 5 methodologies to look at when talking about virtualization techniques in cloud computing. 1. Network virtualization. 2. Storage virtualization. 3. Server virtualization. 4. Data virtualization. And 5. Desktop virtualization.
After our friend explained the cloud computing and grid computing, now I will explain to all of you about what is distributed computation in cloud computing. The distribution in Indonesian dictionary has a meaning of distribution or divide or delivery to some places, while computing is an algorithm to solve the problem. If they are combined, then the distribution of computing is a collection activities of some computer, which is connected to conduct the distribution, such as send and receive data and perform other interaction between the computer where a network. This is all done with cloud computing to provide service when the information is stored on the server permanently and stored on the client computer in temporary. Distributed computing is one of the growth of cloud computing because it offers accessing resources in parallel and users can also make it simultaneously. In the computational distributed runs through the coordinate use of computer physically either separate or distributed. In this computational distribution, the program is separated into several parts that run simultaneously on many connected computers across the internet network. In distributed computation, have the third main point. The first is computer from hand. a media interface for interaction between users with computers. Front-end usually contains a display design application for face-to-face between user and computer. Second, computer backend, a place where it contains the front-end coding so that the front-end then run. The backend is also usually connected to the server in order to fulfill the client request. And third, liaison between the two, a medium for connection computers with server. Okay, that is the distributed computation in cloud computing.
Now I want to explain you about MapReduce. The reduced map is a concept where continuous data is broken down into small data or data components and spread through the machine. The reduced map can also be said to be a useful framework for processing data on cloud computing concepts. In the process, the map data reduce is divided into two main processes. There are map and reduce process. The map process works in collecting information from the pieces of data pieces distributed on each computer in the cluster or group of connected computers. After that, the result of the map process will be submitted to the reduce process for further processing. Then the result of the reduce process or final result will be sent to the user. One example of application MapReduce in a product is in the open source realm. In the realm of open source, visible acceleration development of other framework that is distributed and using the same concept. The project name Apache Hadoop made by Google. This is the picture of the MapReduce process. The first one is map function. Is assigned to read inputs in the form of key or value pairs, then generate output of key or value pairs as well. The key or value pair function of the map folder is called the key or value intermediate pair. Then the shuffle function will read the key or value intermediate pairs resulted from the folder function and merge or group them by key. Otherwise, each value that has the same key will be combined in one group. The reduce function also generates the output of a key or value pair.
Now, I will explain about NoSQL database. NoSQL is an approach to database that represents a shift away from traditional relational database management system (RDBMS). To define NoSQL, it is helpful to start by describing SQL, which is a query language used by RDBMS. Relational database rely on tables, columns, rows, or schemas to organize and retrieve data. In contrast, NoSQL database do not rely on this structure and use more flexible data model. NoSQL can mean not SQL or not only SQL, as RDBMS have increasingly failed to meet the performance, scalability, and flexibility needs that next generation data intensive application require. NoSQL database have been adopted by mainstream enterprises. NoSQL is particularly useful for storing unstructured data, which is growing far more rapidly than structured data and does not fit the relational schema of RDBMS. Common types of unstructured data include user and session data, chat, messaging, and log data, time series data such as IoT and device data, and large objects such as video and image. Common types of NoSQL database. 1. Key value model. The last complex NoSQL option, which store data in schemaless way that consists of indexed key and values. Example, Cassandra, Azure, LevelDB, and Rian. 2. column store or wide column store, which store data tables as column rather than row. It's more than just an inverted table. Sectioning out column allow for excellent scalability and high performance. Example, HBase, Big Table, Hypertable. 3. Document database. Taking the key value concept and adding more complexity. Each document in this type of database has its own data and its own unique key, which is used to retrieve it. It is a great option for storing, retrieving, and managing data that's document-oriented but still somewhat structured. Example, MongoDB and CouchDB. 4. Graph database. Have data that's interconnected and is represented as a graph. This method is capable of large complexity. Example, Polyglot, Neo4j. And next, difference NoSQL and SQL. 1. The main difference was seen between SQL and NoSQL in the way of writing their database. 2. NoSQL does not use a relational schema. 3. Have the ability elastic NoSQL better than SQL. 4. Integrated caching. NoSQL has the ability to transform the data more quickly. 5. SQL databases are more emphasized on the properties of atomicity, consistency, isolation, and durability properties, while the NoSQL follows the consistency, availability, and partition Brewer's theorem. Next, apps that use NoSQL: Facebook, LinkedIn, Amazon, Google, and Twitter.